Physics is one of the fundamental part of science which can relate the things that are happening around us on a regular basis. There are many laws in physics and many might even despise it for not understanding its core meaning or consider it to be all talking. When we speak about the motion of stars and the variables that are affecting the galaxy we live in, and all other relativistic, or even quantum approaches that are effective in explaining or assuming the happening near us or many light years away from us. The purpose of this video is to make simple physics laws seem applicable to ordinary us with relatable examples. Here are some basic physics laws that even non-science students can understand. These laws provide a foundational understanding of various aspects of physics and their practical applications. Newton's first law of motion, law of inertia. An object at rest stays at rest, and an object in motion stays in motion unless acted upon by an external force. This means that objects don't change their state of motion by themselves. They require a force to start moving, stop moving, or change direction. For example, a book sliding off a table unless stopped by friction. A car continuing to move forward after the engine is turned off. Newton's second law of motion. The force acting on an object is directly proportional to its mass and acceleration. In simpler terms, this law states that the more force you apply to an object, the more it accelerates. Similarly, the more massive an object is, the more force it takes to accelerate it. For instance, pushing a shopping cart harder makes it move faster. It's easier to push an empty box than a heavy box. Newton's third law of motion. For every action, there is an equal and opposite reaction. This means that when an object exerts a force on another object, the second object exerts an equal and opposite force back on the first object. Like as recoil when shooting a gun, balloons flying forward when air is released. Law of universal gravitation. Every object in the universe attracts every other object with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. In simpler terms, this law explains why objects are attracted to each other due to gravity. For example, objects falling towards the ground when dropped. Planets orbiting around the sun due to gravitational attraction. Archimedes' principle. An object immersed in a fluid experiences an upward buoyant force equal to the weight of the fluid it displaces. This law explains why objects feel lighter when placed in a fluid, like water, because the fluid pushes upwards on the object with a force called buoyancy. For instance, feeling lighter when swimming or bathing in water. Balloons floating in the air due to buoyancy. Ohm's law. The current flowing through a conductor is directly proportional to the voltage across it and inversely proportional to its resistance. Simply put, Ohm's law describes the relationship between current, voltage, and resistance in an electrical circuit. Such as brightness of a light bulb increasing when the voltage is increased. Current flowing more strongly through a wire with less resistance. Boyle's law. For a fixed amount of gas at a constant temperature, the pressure and volume of the gas are inversely proportional. This law states that when you increase the volume of a gas, its pressure decreases, and vice versa, as long as the temperature remains constant. For example, a balloon shrinking when taken to a higher altitude. Squeezing a plastic bottle decreases its volume and increases its pressure. Hooke's law. The force exerted by a spring is directly proportional to the displacement of the spring from its equilibrium position. This law explains the behavior of springs in elastic materials, stating that the force applied to stretch or compress a spring is proportional to how far it is stretched or compressed. For example, a spring stretching when pulling on it. A rubber band returning to its original shape after being stretched. Snell's law of refraction. The ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant when a light ray passes from one medium to another. In simpler terms, Snell's law explains how light bends or refracts when it passes from one medium, like air, to another, like water or glass, as a straw appearing bent when placed in a glass of water. Light rays appearing to bend when passing through a prism. Conservation of energy. Energy can neither be created nor destroyed. It can only be transferred or converted from one form to another. This law states that the total amount of energy in a closed system remains constant, although it can change from one form to another. Such as swinging pendulum, with the potential energy converting to kinetic energy and back. Throwing a ball up in the air, with its potential energy converting to kinetic energy and back. Law of conservation of momentum. The total momentum of a closed system remains constant if no external forces act on it. This law states that the total momentum, mass times velocity, of a system of objects before a collision is equal to the total momentum after the collision. Such as billiard balls colliding and transferring momentum from one to another. A person on a skateboard throwing an object, causing themselves to move backward. Coulomb's law. The force between two charged objects is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. Coulomb's law explains the interaction between electrically charged objects, similar to how the law of universal gravitation explains the interaction between objects with mass. For example, Static electricity causing hair to stand up when rubbed with a balloon. Repulsion between two negatively charged magnets. Faraday's law of electromagnetic induction. A changing magnetic field induces an electromotive force, EMF, in a conductor. This law describes how a magnetic field can induce an electric current in a nearby conductor, such as in a generator or transformer. Such as generating electricity using a dynamo on a bicycle, charging a phone wirelessly using an induction charger. Pascal's law. Pressure applied to a fluid in a confined space is transmitted equally in all directions. Pascal's law explains the principle behind hydraulic systems, where a small force applied to a small area can be amplified to produce a larger force on a larger area. For instance, hydraulic car brakes using a small force on the pedal to generate a larger force on the brake pads. A hydraulic jack lifting a heavy object using a small input force. Ampere's circuital law. The magnetic field around a current-carrying wire is proportional to the current and inversely proportional to the distance from the wire. This law quantifies the relationship between the magnetic field produced by a current-carrying wire and the magnitude of the current flowing through it. Such as the magnetic field created by a current-carrying wire deflecting a compass needle. Magnetic field generated around a wire when current flows through it. Gauss's law. The total electric flux through a closed surface is proportional to the total charge enclosed by the surface. Gauss's law is a fundamental principle in electrostatics, relating the distribution of electric charges to the electric field they generate. Such as electric field lines spreading out from a positively charged object, lightning occurring due to the buildup of charge in storm clouds. Bernoulli's principle. As the speed of a fluid, such as air or water, increases, its pressure decreases. This principle explains the relationship between fluid velocity and pressure, often used to understand the lift generated by airplane wings or the flow of fluids through pipes. For example, airplane wings generating lift due to the difference in air pressure. Water flowing faster through a narrower pipe, causing a decrease in pressure. Planck's law of black body radiation. The intensity and spectrum of radiation emitted by a black body at a given temperature is determined by Planck's law. This law describes the relationship between the temperature of an object and the spectrum of electromagnetic radiation it emits. Some examples are as the red-hot coils of a toaster emitting light and heat. A glowing incandescent light bulb producing both visible light and heat. This is not the end of existing laws, but these laws cover a wide range of phenomena and provide further insights into various aspects of physics, and the examples demonstrate how the laws of physics are at work in our daily lives, often in ways we may not always notice.